I'm very curious about how you're using artificial intelligence to optimize a lot of these delivery systems. So please enlighten us.
Sure, absolutely. Well, you can imagine that AI is really good at solving complex problems when there are many, many variables to explore. And optimization is one of these classic industries that is limited by sequential computing power. But at the same time, AI is a great bridge to that. It's a massive enabler of doing more with the hardware that we have today and making it much faster and more responsive. And so I'll give you some examples of that because we've worked in a number of interesting projects where if we didn't have AI, we wouldn't be able to adapt in real time to some of the real challenges on the road.
We're going through something absolutely historic.
Technologies across the board are growing exponentially.
It's a disruption that's going to completely redefine the way businesses compete.
In the next decade, we're going to lose 40% of today's Fortune 500 companies.
The exponential growth of computing is continuing.
AI is nowhere near its full potential.
Whether you like it or not, that the future cannot be stopped by anyone.
Welcome back to the Future Tech and Foresight podcast. I'm your AI host, Mark Verbenkov's deepfake avatar, and this is episode number 213. This episode dives deep into the evolution of logistics and the rapidly growing role of technology in reshaping how goods move across cities and continents. The discussion explores how optimization, artificial intelligence, cloud computing, and emerging quantum capabilities are unlocking efficiencies that dramatically reduce cost, congestion, and emissions, especially in the notoriously expensive and complex last mile of delivery. The conversation also examines why certain hyped innovations like drones may not scale, while invisible infrastructure technologies are quietly delivering massive real-world impact. Beyond technology, the episode looks at the economic, societal, and environmental stakes of modern logistics. From reducing urban pollution and health risks to addressing labor shortages and enabling smarter electrification strategies, logistics innovation sits at the center of sustainability, economic resilience, and city life. Listeners will gain a thoughtful, forward-looking understanding of why logistics matters more than ever and how intelligent systems could redefine what efficient delivery truly means. This episode also explores practical implications such as reducing parking congestion, improving fleet efficiency, and leveraging agentic AI to dynamically optimize delivery routes in real time. By addressing both operational and environmental challenges, the conversation provides a compelling vision for the next decade of logistics, showing how AI and advanced computation can transform delivery networks at scale. Now, a little bit about today's guest. Richard Savoie is the co-founder and CEO of Adiona, which uses AI technology to power millions of efficient, lowest carbon deliveries around the world for brands such as Coca-Cola and Amazon. Richard is a thought leader on transport mobility and AI. Richard has co-founded 3 technology companies with partners including the University of California, Berkeley, an award-winning not-for-profit in Boston, and a 6,000-plus member social network, Engineers Looking for Stuff, ELFS. Great. Rich, thank you so much for coming onto the podcast today. It's a pleasure to have you on, talk about, I hope, some interesting things and to get your interesting insights into this world that we'll be exploring. So thanks again.
Thanks for having me, Mark. I'm really excited to be here.
So the first question I ask all guests is, what brought you into the work that you're doing, into the industry? Was there interest in AI, or was there some interest in logistics, or what initially brought you into the work that you're doing now?
It's interesting, Mark. It was just recently I was having a really long conversation about the origins of my career. And I actually made an insight that I hadn't connected when I was younger. So I'll give you a fresh insight that answers that question. Probably different than the way I've ever answered it before, which is when I was young, I had really severe asthma. And that asthma was crippling at times, but I still had a relatively normal childhood. I was able to play sports and stuff, but it was just a perennial part of my growing up. And I really respected all of these doctors that helped me, the guys that would help me urgently at the ER, as well as my doctors that, would be helping me with prescriptions for inhalers and all the typical asthma things. And I really wanted to be a pediatrician because I thought that was the coolest thing, to be able to help kids who are so helpless. And I was helpless. And I just really respected that they were helping me. I thought that was such a cool calling in life. Desperate to be a pediatrician. If the baseball playing and the astronaut thing didn't work out, I kind of wanted to be a baseball playing astronaut as well. But practically, pediatrician was the backup plan. And then in high school, I fell in love with physics. We did a unit on physics in high school, especially electricity. And so that pivoted my career completely. And suddenly, at age 15, I decided, no, I want to be an electrical engineer. I really want to design circuits and computers and electronics and technology. Okay, cool. And then I went to uni and I ended up studying electrical engineering. And out of uni, I had this amazing discovery where there was this world of medical devices where you could design and build medical technology using electrical engineering skills and basically work with doctors and clinicians to try and help people medically with those skills. And I was like, wow, that is so cool. And it really established a fundamental path for me that I wanted to do things in technology that were socially positive. That was the brief, basically, from a young age, that I needed to meet those two pieces, those two ticks of the box, and then I was off and running. And when I came out of my last medical device company, I was really embedded in that for about 15 years doing medical device development. I decided, well, what's next for me? Am I going to stick with medical technology, or am I going to try something else? And I said, well, let me take my hand at something completely out of my comfort zone and follow a couple of ideas that I had, and they were in the optimization space. I really wanted to look at sustainability, emissions reduction on the transport network, congestion reduction on the transport network. It was just some crazy ideas that I had. And in my mind, they were socially positive, they were reliant on technology, and so they ticked those boxes. And I met my co-founder, who's a PhD in that research space, and we were off and running. So hopefully that's a long way of answering how but I wanted to give it that amount of detail and context, just because obviously people know that they can never really predict where they're going to end up in the early days. But if you establish a North Star, you'll never be unhappy. You'll always be working towards something that you feel is worth working towards.
Right. Well, and I think, one of the key points here is as long as you're working towards something, right? A lot of people just, not to get philosophical, which I try not to do on these podcasts too much, but you can just hope and like dream about something, but if you're not putting any effort behind it, you're not really gonna find what it is that you like. Anyways, that's besides the point. So we're going to be talking a little bit about last mile delivery today, AI optimization, of course, with regards to this. I was kind of hoping to get a little bit of a sense of like the context of the industry, maybe the size of the industry. I think, I don't live in a big city anymore. I lived in Barcelona for 7 years or so, 7, 8 years. I'm now a little bit outside of Vancouver in British Columbia, Canada. If we're going to be talking about logistics, specifically last mile delivery, could you give a little bit of context about like maybe how the industry has changed over the last 5 to 10 years? Like the size of it, like obviously I think everybody has a lot of interaction with Amazon, for instance, but it obviously goes beyond that. Could you maybe elucidate us a little bit on that?
Yeah, well, the first thing that I challenge people to think about when I talk about this, and I'll fill in some of the details, but is to just look around the room that they're in and pick an item and think about how that item got to that room. Think about the materials that it's made out of being dug up out of the ground or chopped down from a forest or wherever those things came from in a manufacturing facility, and then that had to be sent somewhere else. All the raw materials, put together and then sent to a warehouse and then ordered. And whether it's Amazon or whether you're picking it up at a Target, the same principles kind of remain, that we live in a world where supply chain is the backbone of the economy. Without supply chain, everything stops. And we knew that during COVID. We figured that out, obviously. I think it became more high level awareness. But the enormity of the challenges in supply chain are still probably not dinner table conversation for most people, nor should they be. I wouldn't suggest people worrying too much about it unless you have some influence or some reasons to. But it's $1 trillion industry. So supply chain generally is trillions of dollars. And what's interesting to me in the last mile space is if you think about that last step between like a distribution center or a Target to your house, that final movement of a product or a service as well, anything, a human-driven service, is more than half of the total cost of transportation of that item. So if you think of upstream of that last step, every other step that was made of transporting goods and materials is less than that one last step. More than half. And the complexity of that last step drives the cost. And it's something that's challenged supply chain professionals for years and years and years. Now, about you said about 5 to 10 years, but let me just go back about 20 years, right? 20 to 25 years when GPS became first widely available, right? The satellites have been there for a long time, but then governments, especially the US government, started opening up GPS availability for other people to use. And that was an absolute game changer. And so you saw companies like UPS notoriously came up with what they call their Orion system. And that was a last mile delivery optimization system reliant on GPS in the sky to help to optimize those movements. And some people might have heard of these old adages about in North America, at least, 3 right turns being less than a left turn. And down here in Australia, it's the opposite. Sometimes, 3 left turns is less than a right turn, because going, contiguously around a block with traffic can be a lot less time consuming than crossing over a busy road or something, right?
Mm-hmm.
So these are the types of insights that started developing in this mathematics and research community around, wow, there's so much more that we can do to optimize this space now that we have GPS. Then you fast forward to about 5 to 10 years ago when cloud computing became more pervasive. And we got this open opportunity to use cloud services from AWS, and we used Google Cloud, GCP, Microsoft Azure, Alibaba, all these cloud providers. Now you can deploy software at scale that leverages GPS, and you can parallelize the computations required really dramatically. And so for anybody in the kind of optimization software world, knows how complicated it is, but let me just give you an example for an average person. If you have 10 different locations that you have to visit, so say you drive a van, you got to go and deliver 10 things in Vancouver, there's millions of different combinations of roads that you can take just to deliver 10 items. Now imagine you're Canada Post and you've got thousands and thousands of things to deliver. You've got hundreds, maybe thousands of vehicles, and it's all just raw data. Somebody's got to either sit there and do it manually on a map, or you're going to use technology. And that's where what we do in using AI really changes the game in automating some of these processes that are very, very difficult for human brains to figure out. And until 5 or 10 years ago, were almost impossible to solve because you'd be reliant on your own custom computer sitting in your basement as an organization. And unless you have access to supercomputers routinely as a trucking company, you're probably not going to have those.
Right. So again, to maybe to double click a little bit on the savings here with the scale of what we're talking about. So you're saying, if I understood correctly, 3 right turns, if you do that, you could be saving 50%, 100% instead of going 1 left turn across a fleet of vehicles, theoretically. Are we finding large scale optimizations now, or have those optimizations already been found? Are we kind of minimizing and maximizing the improvements, or are we still finding large areas of optimization with AI and some of the other technologies that have been developed over the last 5 to 10 years?
It's a great question, because this research field has been around for decades. So it's been studied for, since the 40s, since the 50s. And so there's definitely some areas that there's not going to be much to improve on, but there's other new areas that are really exciting. So I'll give you a quick example. That example I gave you of 10 locations to visit in Vancouver, they call it the traveling salesperson problem. And it's a classic problem in optimization of what's the most efficient route between a certain number of points with one agent. So 1 van, 1 truck, 1 person. And then you've got a level up, which is you've got thousands and thousands of locations with hundreds of vehicles. Okay, now what's the best solution for that? Which is way, way harder to do at scale. And then, that's an area that now has a lot more research available to be done because the computational power and the introduction of AI to help us go that level deeper, that superset of a problem upstream. But then you've also got this ability to impact carbon abatement at a scale that we have not been able to before. And let me just give you an example as to why, because the savings in dollars tend to correlate to savings in carbon emissions. And that's where I get really excited, because if you look at other competing technologies that abate carbon in one way or another, whether it's capturing carbon or whether it's electrifying vehicles, they're all far more expensive than simply optimizing the resources you already have. And because the Western world, we're going through this massive transition of trying to electrify vehicles. Commercial transport is responsible for half of the transport emissions, but yet is much, much harder to electrify or to convert to hydrogen or other low emissions things. So you've got this massive legacy of diesel and petrol vehicles that are going to be around for decades still. And you can say, well, we want to electrify and we can throw money at it. But if I'm a big transport company, there's only so many that I can do. I don't have infinite resources to just electrify everything. But if I can use software and AI to optimize those resources and shave 10, 15, 20% of my vehicles out of the pool to do the same amount of work, suddenly you've got a massive impact of carbon abatement that you can achieve while also reducing costs, generally about a linear amount. You're going to reduce your costs because, say, you reduce your vehicle pool by 15%. Obviously, you're saving all that running costs, you're saving the labor, you're saving the insurance, the fuel, maintenance, everything that goes along with that. And you've got the emissions reduction as well as a sweetener. And so when we're working with these programs, and we're working with big companies, because we work with Coca-Cola, PepsiCo, we're in Australia, so we work with Australia Post. We've done some work with Walmart. We've done all sorts of really cool projects. And it's a SaaS program, SaaS platform that allows any of these fleet operators to get those financial savings while also reducing their emissions. And so it appeals to the entire organization.
Right. Okay, so that sounds like it's quite a large scale optimization that can happen. I don't know if we want to spend too much time on this point, but when it comes to, I think what gets a lot of attention in like headlines is the autonomous guided robots or vehicles on sidewalks that are doing that last mile delivery of pizza or food or drinks or whatever. Um, I'm assuming that makes up like a fraction of a percentage of the actual last mile delivery. I'm assuming also that the percentage is growing over time as these um, vehicles get a little bit more proficient in what they're doing. Is it worth touching on that, or is it the scale of that so minor that it's not really making a difference in your eyes?
Thank you for asking that, because in our early days, we got a lot of pressure from investors to pursue that market, specifically because it is enormous. But it's enormous because it's very distributed. It's a lot of individuals getting individual delivery. And I think we can all imagine how hard it is when you're getting DoorDash or Postmates and for them to bundle in other types of deliveries with your delivery, because then your pizza will be cold. And, there's all sorts of problems there. So there's a very hard limit as to how much you can consolidate those things. We call it consolidation. Whereas on the kind of the other type of logistics movements with parcels, e-commerce, shipping, stuff that's not temperature sensitive going to an end consumer. And I shouldn't have said that. So stuff that is temperature sensitive, but is at scale. So, companies like Martin Brower that service McDonald's all over the world, and deliver all the inventory of burgers and buns to McDonald's. Yeah, there's a lot of consolidation and efficiency that you can create at scale with those. Not so much at the end delivery of food and fast moving consumer goods or so quick service commerce, quick service stuff. Now that said, there is opportunities there, but I just think it's not the low hanging fruit.
Right. And do you see that growing in the future with technology advancements, or is that like, there was first these autonomous guided vehicles, and then, there's lots of discussions about drones being used for last mile delivery, maybe even having like drone pads for a neighborhood, and, there's a kind of a landing pad and stuff. Like, my sense is a lot of this is like really cool stuff that grabs attention in headlines, but it's maybe not as valid as, say, like what you're talking about, which is, an actual scale optimization that can actually be done.
Yeah, look, a lot of it is marketing BS. Amazon came out with their drone plans 10 years ago. It was 2015 when they first announced that we would all be receiving packages via drones. And how many of you have received those? A few people in Arkansas have gotten them from Walmart, but it's not at scale, and it's nowhere close to scale. Now, that said, I'm not some futurist. That's not my role. I've always been skeptical of it by the pure economics of it, the numbers. If you run the numbers on it and you realize, just like consolidation of DoorDash and Postmates or quick service stuff, the numbers just aren't there to support there being any kind of commercial incentive to do that. The commercial incentives are around redeploying vans and bigger 2-axle rigid trucks that can have a team of either humans or sidewalk robots to go out and do things. That's going to be a way more economically viable efficiency improvement than drones, because the infrastructure requirements, the regulations, all this other stuff.
Right.
So it's just marketing BS. Now, that said, will we have drones in the future? Yeah, I think there will be a time and a place in the future where that will become more useful. I'll give you an example of, use cases that I think are exciting, which is public buses. You've got these, public buses running around. A lot of them are empty a lot of the time. The utilization is low. You could stuff a bunch of parcels and have some drone landing pads on the moving bus on the back. And there's experiments in different cities around the world, and for small, consumer items, cosmetics and toilet paper and things like that are relatively light and easy to deploy. Yeah, I think there'll be some cool use cases in that space, but it's definitely not going to be pervasive or the dominant form of delivery.
Right. Interesting. Yeah. And I think, one of the things that I've noticed for myself, but also for the audience is like, we like hearing about that stuff, but the scale idea is really cool, right? Like if we're talking about a couple, drones and some AGVs on the side of the road, like, okay, that's interesting. But what you're talking about, it adds a little bit more robustness to what's being talked about, right? If we're talking about
Real intense sometimes, So it's not quite as exciting in the headlines, but it's impactful. And trust me, I'll be the first one to sign up for an autonomous bipedal drone to come and deliver me something. I'd be like, yeah, give it to me now. I want to see it.
Right. Yeah, myself included. I want to go back to one of the things that you were talking about, where like traditional ICE delivery vans and trucks compared to EVs. I think there's a lot of focus on EVs in general for consumer and for others. You said that it's not feasible for certain delivery trucks or large scale fleets that are quite large. With what you're seeing, like, is there a real transition that's happening, or is it again a lot of marketing fluff that we're hearing?
Look, it is real and it is happening. And I think that the unit economics are getting better at a rate that it will continue to happen. And you see examples of it in other countries like Finland, where EVs are 95% of the new vehicle purchase. And the UK, where London has a congestion zone, and you go into the center of London and all of the vehicles are electric. And it's pretty cool. But I think it's inevitable. It will happen just purely based on economics. But that's exactly the reason why it's so difficult for freight operators and delivery companies, because they tend to operate in really capital intensive industries, meaning that you have to spend a lot of capital for vehicles, warehouses, property, all these things that, a software business like us, we don't spend money on that stuff. So all your revenue can then be redeployed to other things. So they're in, capital intensive, low margin. So because they have to spend a lot of capital, they have lower margins that they have to operate on. And so I challenge people to just go and look around on the highway and look at the age of the trucks. Look at how old some of these diesel trucks are that are running around, still running, because they'll keep them for as long as they can. Minimum 10 years. Nobody's buying a diesel truck for hundreds of thousands of dollars and getting rid of it within 10 years. So even the most well-meaning freight operator, if they've got a bunch of 5-year-old diesel trucks, you can build any kind of case that electrification is great for them and is going to be good in the long run, but they're going to say, yeah, but I got 5 more years minimum left on these trucks and I don't have a pile of money. And there's not a huge secondary market for those like there is for passenger cars, right? It's much smaller secondary market. So I think those are the challenges that the freight industry is up against that slows things down, even when there's huge incentives at play. We saw, obviously, massive incentives be released at different countries around the world. Canada has, the US has. And still, the industry has moved slow because of those core principles of how their unit economics work.
Okay, perfect. Very, very clear. Should we shift a little bit into what exactly you guys are doing? You touched on it a little bit, but, obviously want to...
Whenever you like, Mark, whenever you like.
Yeah, no, please. Because I think you made a good case for, why the low-hanging fruit, if you will, needs to be focused on now. So I'm very curious about how, like, you're using artificial intelligence to optimize a lot of these delivery systems. So please enlighten us.
Sure, absolutely. Well, you can imagine that AI is really good at solving complex problems when there are many, many variables to explore. And optimization is one of these, classic industries that is limited by sequential computing power. Now, one thing that might be interesting to your listeners, but we'll unpack maybe on another time, is that the real huge opportunity that's coming in the next, say, 10 to 20 years for optimization and freight and all that is quantum computing, which I've been following since the late 90s, to be honest. When it arrives at scale is perfect for optimization because it solves a lot of the parallelism constraints to solve optimization problems. So people can go look into quantum computing and kind of research that if they want. But at the same time, AI is a great bridge to that. It's a massive enabler of doing more with the hardware that we have today, the computing hardware that we have today, and making it much faster and more responsive. And so I'll give you some examples of that because we've worked in a number of interesting projects where if we didn't have AI, we wouldn't be able to adapt in real time to some of the real challenges on the road. So our core business is around not adapting in real time. It's about planning properly for the future, right? So you can do, and we've been doing that for a few years now since we started, helping these people plan their networks and understand what their future network should look like, and then also enabling them to pursue electrification and low emissions vehicles. So that's all stuff that we do on a daily basis with the platform. But the real power of the AI LLMs, especially that have come out in the last couple of years, is around the adaptation and the dynamism that you can achieve with these traditional kind of models. So, for instance, when we first started playing with AI back in 2019, the real challenge that we were facing, that we were using it for then was data normalization. You've got, imagine all of these different companies, all with different software systems in their IT stack. And if they're a big company, they might be on SAP or Oracle. If they're a medium-sized company, they might have something else in the mid-market, Microsoft Dynamics 365 or something like that, or they might have rolled their own and built their own. A lot of these companies, you might not be surprised to have enormous tech teams, and they build a lot of their own software just because it has to be super customized. So imagine, now you've got this ecosystem of data that it all represents the same thing. It represents something getting dug out of the ground, fashioned into an item, and sent somewhere else. That's it. It's really not that complicated. But all these different software systems over the course of the last 50 years have created an enormous amount of complexity in how that data is transacted. So AI is just such a great tool for understanding the atomics. I call it the atomic elements of what all this data means. So where AI can become super powerful is not just in that normalization of data and being able to transact it across all these different systems, but also in the real-time dynamic control of systems. So this is where agentic AI goes way beyond what LLMs can do and allows us this opportunity to be responsive and dynamic on the conditions that are going on a day-to-day basis. So an example that you would face in Canada is snowstorms, blizzards, just foul weather generally. And so we were working on a project with a company in North America that had similar issues delivering medical products. And the challenge, especially for medical products, is that you've got this priority system of things that need to get there because there's actually a procedure or a surgery scheduled, and you really don't want to reschedule that. So the product needs to get there. But then that becomes an easy thing to prioritize. You go, okay, cool. All of the super urgent stuff goes there. Any human can prioritize that. It's not challenging. But for a business at scale, how do you then prioritize everything else? And if you have a snowstorm and, well, let me just say, obviously part of our system is that going into that day, everything was prioritized based on how to be most profitable and achieve the most margin and on time in full delivery and achieve all these metrics. So going into the day, our system has already prescribed what is a really optimal solution. But now roads are closed. There's crashes. Systemic chaos is now taking control. So you can still prioritize the stuff that needs to get there for the patients on the table and whatnot. But for everything else, An agentic AI system can now come in and say, okay, I'm going to recalculate the options based on what's already loaded in the trucks, like what's in my manifest. But my new objective isn't going to be delivering everything on time in full because I can't today. My new objective is going to say, how do I maximize profit? So for all of the remaining items to deliver, which ones should I prioritize, get off the truck, assuming I'm going to have to bring other stuff back on the truck and just not be able to make it everywhere? And that's a game changer because, for a typical day in a situation like that, the uplift in margins for those experiments that we did with them was higher than 20%. So a lot of money back on the table that they would have lost otherwise by investing in agentic AI.
Okay, so awesome. How feasible, or is it even feasible for humans to do that at all in real time? And if it is, how much time does it take to reprioritize in comparison to, agentic AI nowadays?
The short answer is no. There's absolutely, humans have been trying to do that for decades. And I'll tell you what, there's a lot of them that think that they're really good at it. And then you show them how an agentic AI system does it, and they're absolutely incredulous, oftentimes a bit salty. They should be, because they've devoted their life to being really good at this, and they are the best at this. I'll give you an example as well. We built a game, and it's called Route Rival. And I show it at conferences sometimes. I still do sometimes, even though it's this really simple, fun game. And you have a warehouse, and you have 17 different locations you have to deliver stuff to, and you pick the route that you think is best and really efficient, and then our system creates a route, and people always lose. And I had a courier from a big shipping company play the game like 5 times in a row until she eventually got like within 5%.
Okay.
But she was retrying the same areas.
Right. The same areas. Right.
You know what I mean? Like that's really good. The one area trying it 5 times. But if you had to do that at scale every day, the thousands, no way. Humans just can't do it.
So interesting. So again, at scale, if your tech is going to be used by every company across North America, you're going to see some pretty vast improvements. Obviously profit is important for companies, but more like a societal level benefit. You're going to see, CO2 emissions going down. You're going to see maybe less vehicles needed to be utilized. What are some other things that like you could really experience at scale with this?
Yeah, let's talk about that, because that gets me excited too. The enormity of the impact is really outweighed for the investment. So congestion in cities, full stop. Of a majority of congestion, I'd say more than 50% based on all the research that I've read, is caused by people looking for parking. And that sounds oversimplistic, but if you think of the butterfly effect of a single person sitting in a lane waiting for somebody to pull out of a parking spot so then they can go and back into it. Now imagine, that person is a courier and they're picking up a parking spot wherever they can. And then they, couriers, like parcel couriers in cities, spend 60% of their time on foot. And parking is one of the major reasons. They'll park once and then they'll try and do as much as they can on foot because parking's so hard to get and it's so annoying and it's expensive and they might get fined and all these things. So the flow on ripple effects that you have of reducing the number of vehicles, minimizing the number of parking locations that they need to do the same amount of work is enormous. It's actually really hard to quantify, and there's not a good body of research on this yet. It's something that I think we'll invest some time in doing in the future to actually do a bit of before after, comparison. So you've got this congestion reduction, which is enormous. It's very well proven now that vehicle exhaust causes breathing problems and asthma and COPD. And as an asthma kid myself, as I mentioned at the top of the pod, that's close to my heart. And anybody who debates it can go and do the research themselves. Smog in cities is very causal for breathing problems. And I think another thing that people don't know and shouldn't probably know is that there's a massive labor shortage in supply chain and drivers right now. So truck driving is the most popular job amongst high school educated males in the US. Okay, so non-college educated, high school educated males in the US, truck driving, number one. Guess what the fastest growing salary job in the US is? Truck
No way. Right.
less and less people to do it. More and more people are college educated. They're looking for white collar jobs. They're not looking to be on the road away from their family for days at a time. It's a tough job. It's really hard. They should get paid a lot, and safety is paramount. And so there's this massive shortage. Right now, there's 450,000 manufacturing jobs in the U.S. alone that have gone unfilled for more than 6 months. An enormous labor shortage in supply chain, manufacturing, distribution. So we're not stealing anybody's job with automation. This industry, now that said, I don't want to sound callous, because I do think we have a duty of care for the people who've invested their lives in these jobs and have been doing it for 20, 30, 40 years. There should be a transition plan for them. But what's cool about what we do is that, again, when we talk about societal impact, a lot of those people that have been doing this job for years, they spend a lot of time moving around pins on a map, even digitally with Google Maps and stuff, but that's not a good use of their brain. The good use of their brain is relationship management, problem solving, getting on the phone with the driver whose tire just blew or whose air conditioner in a refrigerated truck just blew and has a bunch of berries that are going to go off. Like, they need to be solving those problems, because those are big money problems too, not figuring out where the driver's going to go on a given day. So there's really this massive benefit to investing in these types of automations, not just in what we do, but also in warehouse automation and upstream inventory automation. And there's lots of other AI activity in those places too.
I'm glad that you touched on the labor aspect. The first 100 episodes of the podcast, I rebranded a couple of years ago, but the first 100 episodes was all about technological unemployment and labor issues. Really interesting kind of rabbit hole to go in. I'm also assuming that autonomous vehicles as a new technology that's, it's coming about. It's been coming around for what, 15 years or more than that now, is going to be one of the technologies that's also going to be a kind of a game changer if it ever fully comes, properly emerge into your sector. You mentioned quantum computing. Are there any other technologies on the horizon, kind of looking towards the future? I kind of see that our time is winding down here, that you think will be impactful in your industry?
Yeah, I think that convergence of quantum and AI is going to be really powerful. We know that quantum is going to change a lot about navigation as well. So we're all very reliant on the GPS network for all this navigation and for directions when things change. But it's also a very fragile network. The satellites are old, and they're susceptible to attack and co-opted by third parties or whatever. So quantum is also an interesting technology, not just for computing, but for quantum navigation. So the magnetic field of the Earth actually influences the spin of these quantum particles, and you can basically make a quantum compass that navigates the detailed magnetic field of the Earth. It's really cool.
So cool. I hadn't heard about that before. That's fascinating.
It's really fun to look into, yeah. And you just keep it in your pocket, and you don't need any external technology.
Right, and that would be more precise as well, I'm assuming, than the GPS that we have now.
Precise.
Yeah.
Yeah, because if you can get sub-meter accuracy on a GPS, that's cool. That's really good. You can imagine that's another opportunity for all these technologies to converge, is sub-meter navigation for logistics. So when we talk about autonomous vehicles, when we talk about the robots, especially like sidewalk level robots, you actually don't just need to know where a building is. Like, we don't, to know where your house is. We need to know where your house is. We need to know how to navigate to it on the road. We need to navigate from wherever the master vehicle, say the larger vehicle, can park, to then the access point. And that gets really complicated if you're looking at high-rise apartment buildings and things like that, right? Where you don't know necessarily where you're going to be able to find a parking location, but you have a very defined location for the door, but it may not be anywhere near the center of the building. And it could be on a specific block or a specific corner. And so this is another technology that is still in its early days, because there's companies that are spending an enormous amount of time and money mapping the detailed granular level like that. So now you imagine this detailed data set of the building, the parking locations, the access points, the time windows for when the customer wants to be able to accept deliveries, and also the keep out points, because you don't want to be delivering stuff at 8 a.m. when everybody's trying to get out of the elevator to go to work and school. And then you combine that with this really precise navigation capability that doesn't rely on the internet and it doesn't rely on satellites. And we're talking about a pretty powerful logistics weapon.
Yeah, super interesting. Any other? I mean, that to me sounds, powerful enough. Are there any other things that you've come across that are going to be impactful over the next couple of years?
Look, I think that's the majority of it.
Yeah.
I think,
Yeah.
the other space that we're looking at is just how the consumer habits are evolving. People being more shrewd about what they want out of getting deliveries to home, and using services to get groceries delivered to home is growing pretty quickly. And there's just macro changes in the market that we're always chasing to figure out where we can make the most impact, because we're really mission driven around that. And I think maybe one last thing would be vehicle to grid. So there's a lot of talk about electrification of vehicles, but one of the key parts of that electrification is being able to use the vehicle as mobile batteries. You're not always going to be deploying that charge every day to go out and do your deliveries, or if you own an electric vehicle, to do your commute. So how do you arbitrage the electricity grid to inject that power back in, make money? And we think that there's companies that are able now to actually make a profit off of their vehicles using that electricity grid arbitrage, which is a massive way to offset the cost of the vehicles.
Yeah.
So
that's interesting.
it's early days in that, but I see that as that evolves and as AI evolves to guide that vehicle to grid system, it could be pretty powerful.
Super interesting. Yeah, the more conversations I have on this podcast, the more terrified, but excited I get about the future. So thank you so much for coming on and adding one extra layer of fascination. And I don't think that there was any fear in this one, but just fascination in general. Really appreciate it, Rich.
Thanks, Mark. Thanks for having me and letting me unpack some of these things that people don't get to think about on an average day.
For sure. I'll have your company's website up on the show notes, your LinkedIn, any other places that you are active and you want people to follow and see what you guys are up to.
No, I don't really do X, and the other one's LinkedIn is the part, and YouTube. So if we can get some of the raw stuff, we'll put together reels and things for YouTube as well.
Sure.
To promote your podcast to a new audience.
Perfect. Love it. Well, thank you so much for your time, Rich. Very insightful. And yeah, I always love hearing about like some wacky, new technology that I hadn't heard in the application for it. And that quantum location navigation thing is super interesting. So thanks again.
Well, your curiosity really comes through, Mark. So it makes you a good host because you're clearly quite interested. So I appreciate that.
Yes, very much so. Thanks again, Rich. Well, thanks for listening to this week's Future Tech and Foresight podcast. If you like what you've heard here, there are, of course, a number of ways that you can support the podcast. The best way would be to leave a review on Apple Podcasts or give a rating on Spotify, which you can find a step-by-step explanation for on the futuretechandforesight.com website. Alternatively, feel free to leave a comment either on the episode show notes or the YouTube channel where you can see video recordings of the interviews. And finally, if you are part of an organization that is aware of the disruptive and transformational impact that emerging and future technologies will bring and want to know more, please get in touch to hear about the strategic foresight services that we offer and how we can help future-proof your organization and take advantage of the phenomenal opportunities available to survive and thrive in the future.
A lot of future-shocked people and future-shocked institutions in our society are simply overwhelmed.
Once there is superintelligence, the fate of humanity may depend on what the superintelligence does.
Science fact is catching up to science fiction.
The first truly intelligent machine will be the last invention that humanity needs to make.
The only scarcity that will exist in the future is that which we decide to create ourselves as humans.
Within a 10-year design revolution, we can have all humanity living the highest standard of living anybody's ever known.
Progress is accelerating at an exponential pace, and it's going to reach a point where progress is so fast it's going to be a singularity.
We are probably one of the last generations of Homo sapiens.
Every single headline points to the birth pangs of a Type 1 civilization.